Good morning students, welcome to the new class of physics. So today we are going to discuss the Newton's second law for the system of particle which is rotating about some fixed axis. So let us start. We know that the total angular momentum of this system of particle we write as where we can see here the small L1 is the angular momentum of particle 1, small L2 is the angular momentum of second particle and so on. So the vector summation of all these angular momenta gives us the total angular momentum capital L. Now let us write this total angular momentum in compact form. So that we can write as like this, right? So this we can write as the angular momentum we write as r cross p. So we are writing here ri cross pi, where this ri is the position vector of the ith particle and the pi is the linear momentum of the ith particle, right? Now let us differentiate this equation with respect to time. So we get here d by dt of whole summation ri cross pi like this. Okay, now let us divide it into two parts. So we can write here this is the first part and the second term we write as like this. So now this will become as, now this thing shows us the differentiation of position vector. So differentiation of position vector gives us the velocity of that ith particle. So we can write here vi cross this pi plus now this term this ri. Now this dpi by dt gives us the force acting on the ith particle. So we can write here fi. Okay, so now if we talk about this first term vi cross pi, then this will give us vi cross pi is equal to vi cross m into vi, because the linear momentum is mass into the velocity. Now here the if we keep the mass side, then we can write vi cross vi. So it is the cross product between two same vectors, which is 0, that we already know, right? Now if we talk about the second term, that is this ri cross fi. Now it is the cross product between position vector and the force, which gives us the torque. Okay, so we can write here torque tau I. Now this torque tau I contains two type of torque, the external torque and the internal torque. So we can write as this tau I is equal to tau external plus tau internal. Now the contribution of this internal torque is 0, right? Because we know that this internal torque, it is due to the force between any pair of two particles in this system. Now according to the Newton's third law, we can say that this two forces between any two pair or between any pair of two particles is equal and opposite. So the total force, or we can say the net force, is 0. So that is why this internal torque is 0. So we can write simply the final torque or the net torque acting on the system of particle is external torque. So overall equation we got here is d capital L by dt is equal to tau external. So this is the Newton's second law for this system of particle. So today this is enough for today. In the next session we will see some more topics of this same chapter. Thank you.